Hello friends, today we're going to talk about applying congruence of triangles. Just a real quick note, I will not be in class tomorrow, so when you come into class, go ahead and get in your CTGs. Please make sure that you work diligently. All of your homework or your classwork from yesterday or today and tomorrow will be due on Monday. So again, make sure you are working diligently in class, and we'll grade that on Monday. Again, this is your last weekend before your zombie project is due, so also make sure you're working on that. All right, let us begin. We're going to talk about congruent figures. Okay, so we talk about congruent figures. We're talking about all parts being congruent. Okay, now we are talking about triangles specifically, so let's talk about their parts. What parts are we talking about? When we're talking about a triangle, we're talking about their sides, okay? And we're talking about their angles, okay? So like angle D here, angle E, and angle F. So we're talking about 6 total parts, 3 angles, 3 sides, okay? We're not talking about the vertices that are included with triangles, just the 3 angles and the 3 sides. So if all 3 of those are congruent, like what we see here in our triangles below, okay, then you're going to see congruent triangles. Okay. Now let's talk about corresponding parts. The corresponding parts are very similar to your corresponding angles that we learned with our parallel lines and our transversals. Corresponding parts are congruent parts of, are the congruent parts of congruent figures. So basically a corresponding part is a part that's in the same place as the other figure. So here AB is in the same place as DE in our triangle. They are congruent. BC is in the same place as EF. They are congruent. DF and AC are in the same places on their respective triangles. So again, corresponding parts are just the parts, they're in the same place on the other triangle. Okay, pretty self-explanatory. Okay. So if we're looking at these triangles and we say that triangles ABC is congruent to triangle DEF, I want to point out a couple things. First of all, notice that AB, we said a second ago, was congruent to DE. Notice how the order it's written. Okay? If you notice the order it's written, it'll help you identify if it's congruent or not. So in this case, our order says AB should be congruent to DE. The first 2 letters should be congruent to the second 2 letters. Just like BC should be congruent to EF. So is BC congruent to EF? Absolutely. And in this case, AC should be congruent to DF, skipping out that middle term. And that is how it works. When we name a figure, no matter how many sides that we have, we need to make sure that we name that figure in a circular pattern. So like A, B, C, okay? Or in this case, D, E, F. Those are triangles D, E, F. Or you could say triangle F, D, D, E, okay? Or F, E, D. Just a circular pattern, okay? So is BAC congruent to what triangle? I just showed you the answer, my mistake. BAC is congruent to, and how do I write the congruent triangle to BAC? I have to write in the right order, which would be EDF. I've got to make sure I match the parts, match the corresponding parts, okay? This tells me that AB is congruent to DE. We already talked about that. BC is congruent to EF. We've gone over that. And CA is congruent to FD. Again, corresponding parts. Now let's look at these. What angles are congruent to each other? Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Okay, A and D, B and E, C and F. Again, corresponding angles. So we have 3 corresponding sides, 3 corresponding angles, which could conclude that these 2 triangles are corresponding because all of their parts are congruent. Okay? Let's look at these 2 triangles. Now, in this particular case, we're given 3 corresponding sides that are congruent. So AB is congruent to ED, and BC is congruent to EF, and AC is congruent to DF. But let's take a look at the angle measures, okay? It says angle A is 56, angle B is 67. Over here it says angle D is 56, angle E is 67. Do we know angle C and angle F? Well, sure, all we have to do is add 56 plus 67, so A plus B, and subtract it from 180, so 180 minus A minus B, or you could have set it up with A plus B plus X equals 180. So either way you set that equation up, it doesn't matter. But basically adding these two together and subtracting from 180, we get 57. Okay, what about over here? Okay, is that going to work out the same? Yeah, the same thing. 180 minus 56 and 67, and they're both 57. Okay, now what we just did is basically proved a theorem. This theorem that we just proved is the third angle theorem. And what the third angle theorem says is if two angles of one triangle, so two angles of this triangle here, the 56 and 67, these two angles, are congruent to two angles of a second triangle, so 56 and 67 here, then the third angles are also congruent. So once I figured out that this was 57, I would have already known this is 57. Again, this is another theorem in which it's common sense because, again, we just, if I asked an average person who's not in geometry, hey, could you tell me what the angle measure of C is? They'd say, yeah, 56 was 67 minus 180, 57 degrees. Okay, well, could you figure out what angle F is? Sure, 56 plus 67 minus 180 degrees equals 57. That's an average person can use common logic and common sense to figure this out, but in geometry we have a theorem that says, hey, if C is 57, and A and B are congruent to D and E, then that means F is 57 as well. Okay, so our third angle theorem, make sure you write that down somewhere so you have it for later for when we do the proofs from time to time. Again, we'll do one here in just a minute. And as always, if you have any questions, please feel free to ask me. Oh, speaking of the proof, we said we'll do it in just a minute. We'll do it right now. Now we're given two triangles. What we want to do is we want to prove that triangle HIG is congruent to triangle JGI. Okay, and what we're given HI is congruent to GJ. Okay, a little different spot, but again, the order should be the same. We're also given that HG is congruent to IJ. And we're given the angle IGH, so this angle right here, is congruent to JIG, angle JIG there. Okay, these are congruent. And angle JGI is congruent to angle GIH. So these two angles here, these two angles here are also congruent. So what are we missing? What do we not know right now? We've covered these two sides and these two sides, so what side are we missing? Yeah, IG. We didn't talk about IG. What angles are we missing? Basically, we're missing angle H and angle I, or J. Okay, so let's work on our proof here. Okay, we first need to figure out, in order to make our proof true, we have to determine that all 6 parts are congruent. So let's start with the side. We need to determine that the side is congruent. So what side do we say we have left? Well, we only have one side left, which is IG. But that one side is the same side for both triangles. Okay, so IG goes with HIG and IG goes with JGI. So how could you say that IG equals IG, or IG is congruent to IG? What property is that? Hopefully you said the reflexive property, and then you'd be right. IG is IG. Okay. Now we need to figure out, and we need to prove that angle IHG, or angle H, is congruent to IJG, or angle J. Okay. Well, what allows us to prove that? Hint. Wink, wink, we just talked about it. That's right, the third angle theorem, because we know that this angle is congruent to this angle in this triangle. This angle is congruent to this angle in this triangle. So we know that two angles in one triangle are congruent to two angles in another triangle. If that's the case, then the other angles are congruent as well. So finally, now we've proven that we know that 1, 2, 3 sides are congruent, and now we know that 1, 2, 3 angles are congruent. So that's our 6 parts. So now we know that triangle HIG is congruent to triangle JGI, and that is our definition of congruent figures. All parts are congruent. Not too bad. Not too bad. Okay. And honestly, that's pretty much it. So let's go ahead and let's take a look at some examples. Okay, when I look at these two shapes, I have two quadrilaterals of some sort, kind of look like trapezoids to some degree. But notice it tells me that ABCD is congruent to EFGH. Okay, so AB should be congruent to, based on the way it's written, EF, correct? So if I'm trying to solve for X and Y in these two figures, if I know that AB is congruent to EF, how would I solve for X? Pretty simple. Set 3x plus minus 6 equals to 9, right? Because they're congruent. Then all I have to do to solve is a simple algebra problem. Add 6 to both sides, you get 3x equals 15. Divide both sides by 3, you get x equals 5. So now if I know x equals 5, I can plug that into this equation, and that gives me 4 times 5 is 20 plus 2y. So 20 plus 2y, what does that equal? What angle does that equal? Well, based on our order of the way it's written, D and H are in the same spot. Our pictures indicate that D and H should be congruent. So 20 plus 2y should equal 44. And then again, we just have a simple algebra problem that we have to solve. Subtract 20 from both sides, you get 2y equals 24. Divide both sides by 2, and y equals 12. Very, very simple. Okay. And then finally, let's take a look at this one. Here we have, basically, we have, well, I don't want to tell you what we have because it'll kind of throw away the answer, but you can kind of look and see what you have here. And we want to figure out what the angle measure of GFE is. So find the measure of GFE. So this angle measure right here. We know that these two angle measures are congruent at 35. We know this one is 40. And we know this one is 40. So how do I find the rest of this one? Go ahead and pause the video for a second and see if you can't figure it out on your own. All right, hopefully you're back, and here's what I'm looking at here. First, I'm going to look at this. What do you notice here? Okay, you should notice you have a triangle there. If I take this angle measure and move it here, okay, because I know these are congruent, that's 35. So here's our triangle again. Well, maybe. So then I have 40 plus 35 is 75. And then I know all triangles equal 180 degrees. So 180 degrees minus 75 equals 105. Okay. There's several other ways you could have gone about this, more difficult ways, more easy ways. You might have also seen this triangle here. And you could have moved this angle over here. Maybe you saw this triangle here. Well, I can't point it out, but this triangle right here, and had 35, and 35 is 70, and this is 110. And maybe you have 110 here and work your way around this, and since this is 110, then you know that this is 70, 70 and 40 is 110. Okay, this, I'm sorry, 70 and 40, yeah, is 110, and this must be 70 as well. 70 plus 35 is 105. Again, much more complicated, but you could have figured it out a couple different ways. All right, let's look at one last example. What do we have here? Let's go ahead and we have two triangles, and notice you have angle I and angle L are congruent, angle J and angle M are congruent, angle K and angle N are congruent. So it's three sides that are congruent, okay? And assuming that three angles that are congruent, assuming all three sides are congruent, now you have two congruent triangles. So IK must be congruent to, so IK is congruent to which side? Now look for the 1 and the 3 angle markings. That must mean it's congruent to NL. Okay. JK must be congruent to, so here's JK, got 2 and 3, 2 and 3, that must be MN. Oh, sorry, looking at the wrong one. Measure of angle L is equal to 44 because the measure of angle I is 44 degrees. Okay, we already said JK is MN. LM must be JI, they're swapped, or 8.2 centimeters, and JI is congruent to LM. And that's all she wrote. And if you go back over here, there's our classwork for tomorrow. Have a great day, and I'll see you on Monday.